All right, ladies and gentlemen, we're looking at 1.4 angles and their measures. Okay, so an angle consists of two different rays that have the same initial point. Right, when we talk about initial points like this, here's my initial point, and here are two rays. Two rays with the same initial point forms an angle. The rays are the sides of the angle, and the initial point is also called the vertex. Angles that have the same measures are called congruent angles. A point is in the interior of an angle if it's between the points that lie on each side of the angle. A point is in the exterior if it's on the angle or in the interior. Okay? So let's do this. Interior point. Ta-da! Exterior point. Any of those. An acute angle is cute. It's between 0 and 90. It's cute. It's little. A right angle has a measure of 90. And obtuse, it's like obese. It's bigger than 90, less than 180. And a straight angle is 180. And here's some very, very important postulates that you should be writing down. The protractor postulate. Consider point A on one side of OB. The ray of the form OA can be matched to 1 with the real numbers 0 to 180. All this means is that when you take out your protractor and stick it on an angle, if it says measure the angle, it works with a protractor. Kind of like the ruler postulate. The measure of angle OAB, denoted by measure angle AOB, is equal to the absolute value of the difference between the real numbers OA and OB. That's just saying it should always be positive. Angles aren't negative. The angle addition postulate, so this is very similar to our segment addition postulate, except we're dealing with angles. Okay. I love my computer. I love my computer. Yeah. 1 second, please. So I think angle addition postulate works best when we draw a picture. If we've got angle RST and then RSP and PST, so we've got angle RST and angle RSP and PST. When you add them together, they equal the whole thing. So the green one plus the red one equals the black one. We good with that? Okay. We are going to write the names of these angles. So when I say names, this is what I mean. You have to put a little angle in front of it or else you don't get full credit. ABC, or we can call it angle CBA, or in special cases we can call it angle B. That's all it's asking. So, the next one. Yes.
Please put that thing at the top of the recording.
Okay, so angle LMN, angle NML, or angle M. What's important about this is that the vertex stays in the middle. Okay, so for the last one, angle XYZ, angle ZYX, or angle Y. Turn it over. We're going to look at some angle addition postulate. Seriously? No. Just scroll down. That's all I'm asking you to do. All right. You have one more chance, little computer. I might lose it. Okay. We're going to look at some angle addition. We want to find the measure of angle ABC. So what would the measure of angle ABC? And what we have M, angle ABC. What does that equal?
32.
A, B, C, the whole thing?
Yes.
75 plus 57 is 32?
132.
132. Thank you. Getting old, so I can't hear anymore. All right. For B, we're looking at the measure of angle LMN. What does that equal?
120.
Because we have 90 plus 30. Okay. Next one, we know X, Y, Z are collinear, which means it forms a what? Straight line. And we want to know X, Y, W. So what is 180 minus 35? Do you see how I'm doing that? Yes, Eunice? 135.
145?
145, thank you. I told you I'm old. Anybody have a question about those? They think they could do them on their own? Brianna?
Wait, how much was the straight line?
Straight line is always 180 degrees. It says right on the front. So you always take, what I did was I took 180, which is a straight line, minus 35, and that's how we got 145. Good? All right, this is the last one we're going to do because I'm not going to make you do the distance formula again. I'm sorry. Okay, the first thing, we're going to plot all these points. E is at 4, 0. 1, 2, 3, 4. That's E. F is at 3, 2. G is at 1, 0. H is at negative 1, negative 2. And I is at negative 1, positive 2. Okay? So now we're going to connect the dots to form different angles and then classify the angles as acute, right, obtuse, or straight. So the first one we're looking at is HGF. HGF, what would that be? Straight.
We connect the lines.
You can if that helps. E, F, G.
Q.
E, G, I.
Obtuse.
No, I can't spell obtuse. S. F, G, I.
Right.
I would say it would be right. You can't really know. How do you know if two lines are perpendicular? There's something about their slopes. Their slopes are, they're opposite reciprocals. So if the slope of something is 2, your opposite reciprocal would be negative 1/2. So that's really the only way you can tell if they're perpendicular is if their slopes are opposite reciprocals. But I'm pretty sure it's right. We're not going to go through the whole thing and figure it out. E, H, G, I.
Right.
Any questions about this so far? All right, ladies and gentlemen, just so, hold on, let me stop this.